Hello everybody, this is section 7.6 on literal equations. And what is a literal equation but an equation that contains more than one variable? When we say literal, the word literal actually comes from English with letters. So we're talking about an equation that contains perhaps many letters. And we have equations, for example, 3x minus 2y equals 4, which we recognize as the equation of a line in x and y, but that counts as a literal equation. We have more than one variable. And so we have them from physics, we have them from formulas in geometry, from physics, from chemistry, from finance, you name it. So from physics, for example, you might remember there's a formula for, I believe this is the one down here, for our equation in using the free fall motion, right? So the goal in algebra, in the literal equation, is to solve for one of the variables in terms of all of the others. So what would we do? Well, let's just take a basic example right here, and let's take on this formula. This is the formula right here for volume of a cone, of a right cone, right? So in this case, we say, well, the volume is going to be equal to 1/3 times the square of S times H. Sorry, the volume of a right pyramid. My apologies. So the volume of a right pyramid, we can follow for this one, but we want to solve for H. So how do we solve for H? Well, in this case, we're going to multiply to get rid of the fraction, right? So that means we might multiply both sides by 3. Let's get the pen working here. So we would take 3 times the volume would equal 3 times 1/3 S squared H. And of course, the 3 eliminates on that left. So 3 times V is equal to S squared times H. And if we want to isolate H, when we say solve for H, we mean isolate H in the equation. So we would have to divide both sides by S squared. Divide both sides by S squared, and that's it, right? So we would actually find that 3V over S squared is equal to H. Well, that's what we were looking for. We have solved for H in the literal equation, V equals 1/3 S squared H. Now, this skill is very important when it comes to calculus. In calculus, we use these expressions all the time as part of our formulas that we're solving for rates of change and other things like that. And so we want to be able to manipulate these equations so that we can solve for the variable that we want. This is a necessary skill. So let's try a couple more examples right here. I have another formula right here from electricity. It says I is equal to E over R plus small r. We want to solve for small r in this case. Now, when you see a literal equation and you have letters, the capitalization and the little value are going to be different, right? So r does not necessarily equal small r. So you have to be very careful in a literal equation to make sure that you don't mistake one for the other. All right, so how could we do it? Well, this is like one of those rational equations that we had before, where we've got a denominator, but we need to eliminate the denominator. So what I'm going to do on this particular equation is I'm going to multiply both sides of the equation by the common denominator of r plus small r. R plus small r on both sides. All right, so I have an equation that looks like this. I times r, if I distribute, plus I times small r is equal to E. Right? The purpose of multiplying both sides by r plus small r was to eliminate that. So how do we go from here? How do we actually isolate small case r? Well, our next step would be to isolate any term that has small r in it. So that means we have to subtract IR from both sides. So I times small r, it'll be equal to E minus I times big R here. There it is. And now, if we want to isolate r, we're going to divide both sides by I. And this isolates our equation. Now we'll get small r is equal to E minus I times big R divided by I. Now, it's not necessarily the only way to go. There are other ways that we can go about doing this sometimes. For example, in this particular case, we might end up by getting a separate formula, right? An equivalent statement may be something of this nature. If I were to take R and say it was equal to capital E over capital I, and separate it out as a separate fraction, I R over I minus R, right? So we might see that. Well, there are other equivalent equations that we can end up with if we separate things out. So don't panic if you have one form or another. Just make sure that the two things are equivalent. All right, how about this one? This one's a little bit more difficult. We've got A minus P plus RT, and we want to solve for T. Let's solve for T. And you know what? I'm going to do another piece of this where I'm going to solve for P as well. So I'll make that a secondary thing. But if I want to solve for T, what would I do? Well, in this case, this is kind of similar to the last case where I would subtract P from both sides. I get PRT. And so isolating T means dividing both sides by P times R. That's not hard to do. We can get this, and A minus P divided by P times small case r is equal to T, and that is our solution to our literal equation right here. Okay. Well, how about this case, though? Let's say we've got the same equation. We want to solve for P. Well, P is in two terms. What do I do with that? The answer is to use your distributive property and rewrite the equation so that P, if it's part of a couple of terms on one side, factor it out. So we get 1 plus RT. So if I wanted to solve for P in this particular case, by using my distributive property, now all I have to do is divide by the quantity 1 plus RT. So there's a few different ways that we can solve, and even in the same formula for different variables, and isolate them out. The distributive property is a very important tool that we can use. So don't forget to employ that whenever you're doing this. Okay, so that's all I really have in this particular section. It's a very short section. There's a list of homework problems. Good luck.